Hey everyone, I just wanted to do a quick video to help you with what the expectations were for coming up with a calibration curve for homework 3, which is going to be due next week. You can do this totally within Excel. You will need to have your photometer up and running and working. And so what I've done here is I've set up a number of columns in Excel the way that you might consider doing this. So over here, what we have is basically some descriptions of the water that you have. So we don't know what the concentration of the dirty water is, right? The water with the dye in it that Professor McCutcheon has provided. So we're just going to give that a concentration of 1, right? That's going to be the most dirty that the water can be, the most contaminated the water can be. In the handout for the homework, I gave you some information on how to dilute that, right? So if you want to change the concentration of the water, you can of the dirty water, you can dilute it with clean water and change what the concentration was. So for example, if you diluted it by half, right, the concentration would go down from 1 to 1/2 of what it was originally, right? And then if I diluted that by another half again, that would be 1/4, 1/8, 1/16. So this is just an example of how you can choose to do the dilutions for your sample and for your homework. And then obviously the concentration of dye in clean water is 0. So what we see here is we've created a declining concentration in the dye from the most dirty, which is the stuff that you're going to grab from the lab, all the way down to clean water. So what I've done here then is in the next column is this is data that you're going to gather from your photometer. So if you go into the notes or if you go into the video and look back on the day that we talked about spectrophotometry, we talked about things like how you define transmittance, how you define absorbance. And so if you look at that, what you can do is you can basically use your photometer to capture some data based on how much the sample that you have is absorbing light. And so what I've done here is I've entered in, these are dummy values, right? So don't expect that these values are going to match yours. I made these up for the purposes of this demonstration. But for example, if you measure clean water, right, you would expect that would have close to 0 absorbance, right? There's nothing, there's no dye in the water to absorb light, so its absorbance value would be close to 0. And then as we come up in concentration, right, some of the light gets absorbed all the way up to dirty water. So in order to do this, right, you would have your photometer built, you would put the sample in between the light source and the photocell, you would get a reading from the photocell, you could convert that into an absorbance value using some of the mathematics and the equations that we showed you in some of our in class and in some of the examples, and you get absorbance values here. What I've done is I've created 3 columns of those, right? Let's say that you wanted to take 3 replicates of each data point, right? So this is the first time you measured that sample. This is the second time you measured that sample. This is the third time that you measured that sample. So you have numerous data points for each one of those concentrations that you're looking at. What I've done here in this column, column F, is I've calculated the average absorbance. So if I look at what the equation for that is, right, it's basically the average of the 3 absorbance values for any given dilution or any given concentration, right? And in the last column, what I've done is I've looked at the the standard deviation. So what is the variance or the variability in those, right? And that's done with the standard deviation command in Excel. So if I look at that, you can see it's just, again, the standard deviation of the values for a given dilution or a given concentration. So to plot a calibration curve, what I want to do is I want to plot the concentration, right, versus the average absorbance, right? So I need to add in 2 zeros there because that'll be that, right? So I want to look at concentration and I want to plot that versus the average absorbance. So if I highlight those 2 columns and insert a chart, right, I want to do an XY scatter plot, right? There we go. So we can see that is a calibration curve where I've got a concentration along the x-axis, right here. So we should label that, and absorbance here, right? So one of the things that we can do with this is we want to add error bars, right? Since we have some standard deviations on absorbance. So if I click on the data set and I do add chart element, I can add error bars, right? And so we want to do more error bar options, right? And so what we want to do is we want to look at direction both for vertical error bars, right? And we want to do custom, right, and specify value, right? So the positive error value is going to be 1 standard deviation in the positive sense, and it's going to be 1 standard deviation in the negative sense, right? We do that and we hit OK, and we can see that our vertical error bars are changed here. We don't have error bars in this particular case for concentrations. If you did do error bars on concentrations, if you made up multiple samples there, you could include those in this. In this particular case, we're not doing error bars in the horizontal sense. We're not doing error bars in the concentration since we didn't take data with that. So I'm going to highlight the horizontal error bars and set their value to 0, right? And you can see there, if I do that, then I just have my error bars in the absorbance direction, which is great. You can see they vary because the standard deviation for each of the data points is a little bit different. It's not the same for each of those data points. The last thing that I can do here is for my calibration curve is I can highlight the data set again, and I can add a trend line. You can see this is a linear trend. It may or may not be, right, for your particular calibration curve. So think about what it looks like after you get it. But in this case, we can keep that as a linear trend line. And just so that we can see what we're looking at, we'll set to display the equation on the chart as well as the R squared or the goodness of fit value. And so you can see here, this then provides us with the equation of that line. So that would be our calibration curve for that particular photometer with that particular dye and those particular sets of concentrations. So the last thing I might want to do is add, I take my chart again, chart design, I can add axes titles, right? So I'll do a primary horizontal axis title, and I'll do a primary vertical one. And so this is going to be concentration, and that has right now arbitrary units, right? Because we basically did it in terms of the dirty water standard, which we just called 1, and absorbance, right? And absorbance is unitless in this case, right? If we look at the definition of it. So this is, again, absorbance arbitrary units, right? And so the chart title in this case could be, I wish I could type, calibration curve. So what this would let you do, for example, then, is if you took your filtered water, right, water that you put the dirty one in the top of your filter, and you measure what comes out, and then you measure its absorbance, right? So if you measure its absorbance and you find out that it's, say, about 0.2 in this case, then what you could do is you could say, okay, this is what my absorbance reading was. I come over to the line. I look at what the corresponding concentration would be, right? And the corresponding concentration in this case, in this example, would be, again, about 0.2. Right? Whereas fully dirty water was 1. So you can see that in this case you've removed about 80% of the dye in this case, right? This was 1, this is 0.2. You've removed a lot of that dye. So hopefully this is something similar to what you see when you do your when you set up your photometer and you do your calibration curve. It might not look exactly like this. Like I said, I made these values up to give you an idea of how to construct a calibration curve, but that's the general principle. And the idea behind using it is that once you build that, then you can compare unknown values to that standard curve that you've created. A couple of hints or tips: if you find that you're not getting good data with one color LED, switch to a different color. You've got a number of different LEDs that are available to you. Some might be better than others in terms of how they transmit light through that particular sample and that particular dye. All right. Hope that is helpful, and good luck finishing up this homework.